So to start our practice for the Bivariate internal assessment, what we need to do is we need to go to Google Classroom, and what you need it is all here. My first thing to do would be that I would get a copy of the assessment guidelines so that I know what I need to do for each level of achievement, and then I would look at the actual assessment. So the practice assessment is just in here, and when we look at this, we get a better idea of what we need to be doing. So sports science, I draw your attention to the fact that it's about this activity requires students to investigate relationships between physical and or physiological attributes of a sample of high-performance athletes from the Australian Institute of Sport. So next thing, you'll need to understand the given variables, and we will give you time to set aside to understand the variables for the real assessment. You can use technology, and you could do a written report, but we're not going to. We're going to do it with slide and a presentation. So just moving on to the next sheet in this resource. Okay. So here's the introduction. Really read all the information that you get. Sports scientists use statistical information to understand how different variables are related. This activity needs you to carry out a bivariate data investigation using at least 2 variables and to write a report, but we're going to do Google Slides. The relationship between different variables and the performance of the athlete is an area of investigation for those interested in training athletes. You've been given data from athletes collected at the Australian Institute of Sport, and they say use a statistical inquiry cycle to carry out an investigation. Okay, you're going to be firstly familiarising yourself with the data set provided. This will include doing research to help you understand the variables and develop a purpose for the investigation. Next thing, you're going to pose an appropriate question. The variables you choose must be numerical, and the variable you use as your response variable must be continuous. So bear that in mind, really important. You may choose to investigate more than one pair of variables. Select appropriate displays to graph your data. Identify features in the data, including the nature and the strength of the relationship. Fit an appropriate model. Use your model to make a prediction at least or more. Write a conclusion. Support your conclusion by referring to your analysis and or features of the visual displays. Include a reflection on your process, which could consider other relevant variables or evaluate how good your model is. In writing your report, link your discussion to the context and support the statements you make by referring to statistical evidence. Okay, and this is the data that we're going to get. So it's important to have a good look at that. And I'm getting a feeling here, I suspect that there might be some sort of relationship between lean body mass and weight in kilograms. I'm sort of not really sure about all of these, physiological things. I think my hunch is I'm going to start looking at graphs where we have a look at weight and lean body mass. So now I'm back at Google Classroom, and I'm going to download the data. So here it is. It's the CSV file, so that should go quite nicely into NZGrapher. So get that downloaded and then open a copy of NZGrapher. Okay. Now what we're going to do is we're going to choose a file, and that file is we're going to upload we're going to upload the file that we've downloaded of the CSV of our sports data. So here it is. Open it, and NZGrapher now has the data. Okay. I was thinking of wondering about lean body mass and and weight. So I'm just gonna have a wee look at that. Scatter graph, variable 1. I'm thinking that lean body mass is perhaps somewhat likely to affect weight. So there it is. And looking at it, it does look as though it could be something worth pursuing. I'm sort of seeing a nice sort of relationship here, but then there's something else going on here as well. So I'm thinking, I wonder if it's anything to do with gender. So I'm going to colour it by gender. Just, whoa, look at that. So I can actually see there's sort of 2 separate things going on, which is interesting. At this point in time, I'll do my investigation with the male and female athletes together, but it might be worth thinking for excellence of actually separating them out. So my next thing to do would be to fit a regression line, and then I've got the equation for that line, so I can use it to make predictions. And about now, what I personally would do is that I would stop. So what I've done is I've now opened a new tab and I've gone to Google, and I want to find out a little bit more about what this lean body mass actually is, and if I'd actually expect it to affect weight, or could it be the other way around? I need to find out. So the first couple of these, surprisingly not, are from NZQA, so they're talking about the exact data set that we're looking at. This one here looks somewhat reliable, so we'll have a wee look at this and see what we can find out. Okay. So what I'd do is I would find out what I can from reputable resources, for which I'd copy and paste my URL and find out, exactly what it is, what it means. Do I expect females to have higher LBM than males? So, I would have a good look around and see what lean body mass even is, because, you can't study a variable if you haven't defined it. So here I am, lean body mass. Here it is. Bones, ligaments, tendons, internal organs, and muscles. Okay, sort of. I'd probably find more reputable resources in this, but this is a good start. So define the variables that you're working with. Really important to know exactly what LBM is all about. So this article I found here does suggest, when you read it skimmingly, that there is a effect of the kind of sport that the person plays or excels at, and the LBM. So that's interesting. Like there's some suggestion that the aerobic capacity demand of the sport has an impact on the LBM. So we might would save that URL and we'll work with it later. And another article that I've found online suggests that body composition is absolutely crucial, and it does look like a very reputable one. It looks as though it's crucial for athletic performance, and that if you're trying to diet your athlete, then you don't want to lose muscle. You want to lose fat, but not muscle. So what I'd be doing is I would be getting these. I possibly would even print them off. I'd highlight the bits that are useful. Often I just look at the abstract, or, there's some quite good stuff in this paragraph here. So I'd be keeping that to look at later. But hopefully by now I've got a very good idea what BMI actually is. I understand that it's like the essential parts of your body, sort of not the fat stuff, although a little bit of fat is necessary. And I think I will be working with that, the LBM and weight, because let's be honest, if a person's got sort of, average LBM, but a much bigger than average weight, they're probably carrying quite a bit of fat, and that should perhaps affect their athletic performance. So some useful things that I can do with NZ Grapher is I can label the points. So if I want to talk about this one here, I can find that that's point 122, and I can find point 122, and it's a male, he's a field athlete, I can find out a lot about him. So that's useful. Probably wouldn't want to print a graph with it on, but it's very useful to help me to identify what the points are. Here's another thing, I can see that, generally I could actually draw some lines in here, and I could fit a sort of a shaded area to my graph. That could be useful. But I'm actually looking quite hard at comparing males and females on two different graphs. So looking at LBM in males and LBM in females compared for their weight. So let's put on a third variable. Let's put in sex. And now what we've got is we've got actually a graph for males, a graph for females, a graph for males, and there's a lot that we can talk about in there. Yeah, for example, it seems to me that the males conform pretty closely to the line. For the females, there's a little bit more variation away from the line, and that's reflected in the R value. But before you go to R values, talk about what you see. It's really important to talk about what you see. So the equation is for every increase in 1 of lean body mass in 1 unit, the weight goes up on average by 0.991 times that amount. Okay. I'm required to make a prediction, and you can choose anywhere sensible in your range of your explanatory variables. I'm going to choose 70. So for a lean body mass of 70, when I put that through the calculation up here, I get that I would expect a weight of 80. So that's what my prediction is. And I guess I'm reasonably confident in that prediction, although I'm a little bit worried because it seems like the males and females are, the females are sort of higher and the males are around there a little bit lower. Okay, I'd probably do another one, and I'd probably do one at about the 50 kilogram mark. I'm guessing, and we could colour by to confirm this, these are probably the really tiny athletes like gymnasts, and the LBM seem a little bit lower than the trend line. So in this area here, if I'm making a prediction of 40, I don't really feel terribly confident in my prediction. It's not as good as somewhere right in the mid-range in here. And we can comment on those things as well. Now, just to confirm what I could visually see, I've chosen residuals plot. This is the male and the female data all together. And these are the values that the model predicts along here. And these residuals are how far away the actual data values are from what the model predicts. And I can't help but notice this chap up here. We'll have a look and we'll go to point labels and see which one he is. Well, yeah, he's a long way from the fitted model. I would have seen him already on the original graph, but yeah, this is a fair way away. So I'd probably be going back and having a look at this athlete and trying to figure out what the backstory is behind him. And this number 11 too, they might both be of some sport that requires a high amount of body fat, because their values are a long way away, their weights are a long way away from what the model predicts. And do remember, there is quite a strong relationship between the lean body mass and the athlete's weight. So these are quite unusual.